Hello everyone, in this video, we will demonstrate to you the modeling and simulation of Circle K checkout system. There are 7 parts in this video. The introduction to Circle K and the motivation for implementing the system. The questions and purposes. Collecting data. The key parameters and the key operations. Building the modeling and simulation based on Jansim, the result, and finally, the limitation and improvement. Soulgate is a convenience store that sells various items. After the customers enter the store, self-pick up the items, they will enter the checkout area. This checkout area is implemented based on the first-come, first-served principle. In this checkout area, there are 2 next possible scenarios for every customer. Scenario 1, the customers order some food or drinks being made at store. In this case, after paying for the items at counting area, they will move to the food making area to wait for the food. After receiving the food, they will leave the store. Scenario 2, they don't order any food or drink that need to be made at store. In this case, after paying for the items, they will leave the store right away. At some time, when the line in front of the food making area is long, an additional employee is added in order to avoid a long waiting time for the customer. The motivation for implementing this system is that during the peak hours, many customers must wait in a long lines for paying the items at the counting area, as well as wait for receiving the food at the food prepper. Importantly, the Circle K changes its operation mechanism during the peak hour compared with when there is a small number of customers. From this motivation, we start with the main question: how to optimize the system in different periods of time in the day. This model is for the owner or the managers. It wants to give them the information and support them in decision making. For example, should there are always 2 servers, or should they add more servers during the peak hours? The 2 main purposes of this modeling and simulation are modelize the existing model based on the real collected data to investigate which step can we improve. Second, add some assumption in order to examine whether the system works more efficiently. Due to time constraint, our project can only collect the data from 15 p.m. to 16 p.m. On Saturday, May 21st, and 11 a.m. to 12 a.m. on Saturday, May 28th. This period of time is considered as the peak hours. There are 18 customers for the first time we collect the data, and 34 customers for the second time. We observe that the customers are not queued in the self-pickup item process, but they often have to wait in the payment or making process. Thus, we collect the data and simulate the model after customers start to enter the payment areas. Also, for the second time, we observe that when the queue of the food prepper reaches 3 or 4 customers, there is an additional employee comes to help. After collecting and cleaning the raw data, we have the database with 3 attributes. The average inter-arrival time of customer are 2 different time frames. The payment time in which people need to spend to pay for their items, and the waiting time for a customer in food prepper for receiving food. In order to modelize the system accurately on Jamsim, we have calculated some statistic information based on the real collected data. Firstly, we use average inter-arrival time to pass on the exponential distribution, since this follows the Poisson process. In order to determine which time one customer goes to the payment area. Secondly, the probability of a customer entering the food prepper is used to randomly deciding if the customer enters food prepper or leave the payment areas. Finally, for payment and food ordering waiting time, we assume this follows a normal distribution, which is used to randomly generate the time that a payment server serves a customer and the time a customer waiting for their food at the food prepper.
Based on observation of the actual circle case system, we identify 3 main operations for our model. Which are first, the customer go to the cashier to pay for their items, and the second, the customer leave with no ordering food and drink, and thirdly, the customer go to the food and prepper wait for their food and leaves. So I'm going to introduce you our process to build the model on Jamsim. Here is in general process of how we build the model on Jamsim. So there are some first steps that I have mentioned earlier, which are determine the main operations, determine the type, probabilities, distribution for the operation, and also compute the relevant statistics for each operation based on our recorded data. And importantly, determine the number of Jamsim objects for each operation and how each object is linked. And you can see on the left here is how can we is the diagram of the first model, and next when we have the object put it in a position, we have to set and connect all the Jamsim objects together, and then we initialize the corresponding statistics, including the inter-arrival time, serving time, travel time as a parameters for the corresponding objects. And next we will have to set the graph object for visualization. So this helps us to capture the data when we run the simulation. And finally, we simulate the whole system and capture the graph data for analysis. And I'm going to show you our model. So here's our 2 model. So we want to build 2 model because each model represents for each time frame we have collected the data, and specifically the first model has only 1 food prepper server, and the second model have 2 food prepper server, and which is 1 additional server that will be open when the first queue here reach the threshold. And in the second model, there are 2 assumptions at this step. First, when the queue in front of the first server here reach a threshold of 3 customers, we will open the second additional server. And second assumption is they come after customer when this queue reach the threshold is shifted to the additional server, and we do not allow shuffling between 2 queues. So here I'm going to run the simulation on 1 hour, which is actual time that we have collected our data. And you can see here on the left, there are 2 graphs that record the data of the number of the waiting to pay customer at the queue in front of the cashier, and the food and drink waiting customer at the queue in front of the food and drink wrapper. And for the second model, we also want to record the data for the number of customers that have been shifted to the additional server, and which is represented here as the green line on the graph. So for the first model, we observed that the statistic collected in the period, the model show the maximum size of queues in the 2 graphs is 1, and the frequency of the customer being queues is low, which is at the payment area nearly 2 times when the customer having to wait, and in the food and drink there's only 1 time, and which indicate that in this not lunch time area period, there's few customers arriving at the store, and also the making time for food and drinks is low, and therefore it may not be necessary to add another additional server in the food wrapper area. So for the second model, the length of the queues has increased significantly, and also the frequency of the time the customer have to wait in queues. So for the payment queue, the maximum length of queues is 2, and there are 7 times the queues people have to wait in queue. And for the food and drink server, there are 5 times, and this queue reach a threshold, and there are 2 times we have to open the additional server to deal with the long line of customer. This indicates that at this busy period in the day, the necessity to add 1 more employee to the food wrapper to satisfy the last needs of the customers. So in short, with different statistics at 2 different time frames, it is necessary to modify the system of Circle K, and the store has successfully changed its model to satisfy the customer needs. Yes, we have successfully built the model, but there are some limitations. So first of all, we didn't have enough data of the store in different time frame in the days, and also in the same time frame but across days. And however, we have already have a framework to substitute different the statistics of different time frames to obtain analytical result. And the second limitation about it, we did not consider the mechanism within the server. So for example, how the new added server get the order from the long queue. Here we assume that the new added server will take the last customer in the long queue be in front of the first server. And thirdly, we do not allow shuffle between queues when the new server is open. In practice, people often change queue when when they see an empty slot in the next in the besides queues. So yes, this is the end of our presentation, and thank you for listening.